Okay. Right now, am I visible to you? Huh. Okay. First of all, it's a type of support. Okay. Type of support. Huh. Right now. Mhm. This is the supports are of three kinds. Okay. Hello. Hello. Huh. The supports are of three kinds. First one is roller support. Okay. Roller support. It is of like this. Okay. Huh. And when we make the FBT of this, is it will be like this. Okay. Only a single force perpendicular to the position of roller. Okay. Suppose the roller is like this. Suppose the roller is like this, then the FBT will be like this. Getting the perpendicular to the roller's position. Okay. And the next is your hinge support. That is hinge, or you can say it's pin support. Okay. It will be like this. Hinged at this point. Okay. And the FBT and the FBT of this will be like this. There will be two reactions. First one is applying on the vertical side, and the second one is on horizontal side. Okay. And the third one is fixed support. And third one is your fixed support. This one is like this. Okay. This one will be like no, this one will be like this. A vertical, a horizontal, and moment. Okay. This one contain only this. No, no. It will. It is like this. The fixed one is here. The fixed one is here. Okay. That's why it is towards the direction to the beam. Okay. And right now it contains only one reaction, it contains two reaction, and it contains three reactions. Okay, one, two, and this one, three. Okay. Okay, this is all about reactions, this is all about your supports. And right now we will talk about type of loadings. There are three type of loadings. Okay, there are three type of loading. First one is your point load. First one is your point load. Okay, this one is like this. It is particular applying on a particular point. Okay, this one load is particularly applying on this point. The position of this loading is fixed. Hello. this one is particularly applying on this portion, this point. Okay, the magnitude we can write it W, capital W. Okay, and unit of this load is Newton or kilonewton. No, only on that point particular. Suppose this one is 20, this one is 30. Whatever the loading is, it is applying on a particular this point. Okay. Yeah. And the next one is suppose we are taking moment of this. This one be like m equal to w into x. This direction is x. Okay. Yeah. The next one is your UDL. That is uniformly distributed load. Hello. Hmm. Just this one is being and this one is like this. This is your UDL. Okay. This is applying on this like this is applying on this on it like this. Okay. Yeah. Or you can say it will be like this. Okay. Right now it is showing you small w. It is small w, which is Newton upon meter and kilonewton upon meter. Huh? No, no, it's not like a string. It's a sign convention, or you can say it's just a style of showing the UDL. Okay, right now it is small w, which is Newton upon meter. Suppose this one is showing 50 Newton per meter. Okay, over the length of 5 meter. Okay, hello. Huh. Just for an example, it's a 50 Newton per meter UDL, which is applying on the 5 meter length, which means on a 1 meter of span of the length of beam, 1 meter of beam, it is 50 Newton UDL. Okay. Huh. That means the whole loading is capital W is small w into length. Capital W is your small w into length. Okay, and small w is your 50 Newton per meter, and your length is 5 meter. That means ki 250 Newton. Right now, what is this and what is this? This is the loading on 1 meter length. This is the small w is your loading at on unit meter at a particular 1 meter, and this one is 250 Newton is the loading on the whole length on the entire length of the beam. Clear? Right now, right now we are converting this whole loading UDL into a point load. It's like this: 250 Newton working on of the mid of the load, mid of the length. That is 2.5 meter. Right now, is it okay to you? This is the actual actual diagram, and this one is your, and this one is FBD. Is it okay to you? Can you understand? 50 into 5 meter, the length on which this UDL is applying, on which the whole overall your UDL is applying. 50 Newton per meter, 50 Newton per meter into this 5 meter length. Yeah, horizontal, of course. The length of the beam on which this UDL is applying. Okay. Yeah, okay, it's hello. Huh. So right now we are converting this UDL into a point load for the calculation purpose. Okay. So right now this one is 50 Newton per meter into 5. 50 Newton per meter into 5. That is 250. That is 250. Okay. Hello. Yeah. Right now this one is 250 Newton. And right now where is 250 is applying? It is applying on the mid of the length. It is applying on the mid of the length of UDL. Right now, is it okay to you? Can you understand me? Huh? Huh. Okay. Right now, third one is your varying load. That is uniformly varying load. It is like this. That is uniformly varying load. Suppose here it is the value is small w. Okay. And in this case, and this one is suppose ln. In this case, capital W is half small w into length. Okay. Okay. Small w into the length w into half. Okay. Just suppose this one is 200 Newton upon meter. Okay. 200 Newton upon meter. It is the peak value. It is the topmost value of the uniform varying load. Okay. And the length is 4 meter. The length is 4 meter. Okay. So right now capital W is the overall loading. Okay, the overall loading is this one is 200, means it is gradually increasing from 0 to 200. It is gradually increasing from 0 to 200, that is 10, 20, 50, 150, 200. Like this. Gradually it is increasing from 0 to topmost point, that is 200. Okay. So right now capital W is half small w into length. That means it's half 200 into 4, means 400 Newton. Clear? Yeah, area of triangle simply. In that previous case, this one is area of rectangle, and right now here it is the area of triangle, and this one is height, and this one is base. Okay, and this will act at one third from higher end. Okay, at the just like the previous case, the force was acting on the mid of the length, and in this case, it is acting at one third from the higher end. Means like here, it is 4 upon 3 from this side. Okay, and in this and at here it is 8 upon 3. From the higher end, it is 4 upon 3, and from the lower end it is 2 into length upon 3. It is 8 upon 3. Okay, 1 by 3 from this end. You have to calculate 1 upon third of the length. Okay, but one third from the higher side. From the lower side it is 2l upon 3, 2 third. The reason why it is because the center of the triangle will lie from one third from the higher side. And in the previous case, the center of the rectangle will lie in the at the center at the midpoint, in the mid of the overall area. And in this case, this one is one third from the higher side. Okay, is it clear? All the supports and loading. Okay, now we will discuss some type of beams. Your webcam is not working. What happened? Hello. I'm saying your webcam is not working, or what happened? Means I'm not. I can't see you. Okay, okay, okay. And you, am I visible to you? Okay, okay. Right now, type of beam. First one is simply supported. First one is simply supported like this. Okay. The support may be of any type, maybe of roller, maybe of hinge. Okay. First of all, just revise the topic. Right now you have studied about the type of support. These are three kind: roller, hinge, and fix. Okay, and the type of loading. These are of three types: point load, UDL, and VL. Okay, and right now we are talking about type of beams. These are of first is simply supported. In this case, there are two end supports. Two end support means first one is this end and second one is of in at this end. Okay, these may be of roller, may be of hinge, or whatever. Both are hinge, both are roller, maybe. Okay, loading may be of any type: bearing load, UDL, point load, maybe. The main thing is the both end will be simply supported. Both end will be supported by the roller or a hinge. Clear? Suppose continuously beam. Suppose you suppose you have the length of beam is more than the its limit, then you have to give it's more than two supports like this in the mid of the in between of in the length like this, maybe of two, maybe of three. Take it will matter on the length of the beam. Okay, these are the two end supports. These are the in between of the length. Okay, these are continuous beam. Okay, suppose suppose overhanging beam. Suppose overhanging beam. Suppose your beam has an extra length and you have given the support not at the end. These supports are at the end of both end. But in this case, these are not of at the end. These are not at the end. Okay, these are known as overhanging. This one, huh? No, no, it maybe from this side, from this side. ठीक? Okay, this one is overhanging. There is some length at here, some length is at here in the mid, some length. Okay, the fourth one is cantilever beam. The fourth one is cantilever beam. Right now at here, the support is of fixed support. The support is of fixed support. Okay, like this. The support is fixed. Okay, and this end is your free. This end is free. And the fifth one is your totally fixed support. Means your beam is fixed at both the ends. Your beam is fixed at both the ends. Okay, so this one is fixed beam. These are beam, fixed beam, cantilever beam, simply supported beam, continuous beam, overhanging beam. These two fixed supports. Okay, this one contains only one end fixed. This one contains both end fixed. Okay, overhanging. This one contains hanging. It may be of one side. It may be of both side. So this one is single-handed, single end overhanging or both end overhanging. Okay, and this one is continuous beam. Cantilever is one end fixed and this end is free. Okay, no, this if both of one ends are fixed, then it is known as fixed beam. This is totally fixed. This is totally fixed. Okay, this one is totally fixed at both the ends, and this one is one end is fixed and the second end is free. Okay, clear, clear. Any doubt related to this? Any doubts related to these topics right now? Type of hole, type of loading, and type of beam. Hmm? Okay. Now we will solve some questions. Okay. Are you ready? Okay. So then, yeah. Just don't worry. You have to consider first of all type of loading. Which type of loading is applying on the beam, and second one is which type of support is applying on the beam. So both the points are very crucial. Type of loading and type of support. Okay. And right now, this one is beam. Okay. Okay. This one is beam. This one beam is fixed. Suppose this one is roller. Right now, this one is roller. Okay. Both this beam contains two roller support. Okay, and the loads are point load 20 and 30 kilonewton. Just suppose Clear? 1 meter. This one is 2 meter. This one is 1 meter. Is it question is clear to you? Just naming it. This one is A, C, D, B. Okay. Huh. Right now you have to calculate. You have to find out the reaction at both the ends. Okay. Means you have to find out RA and RB. These these two ends contains two roller supports. Roller supports. Okay. Like this. This one is 20. This one is 30. Okay. Clear? RB, RA. Okay. And right now at here, two. Okay. Why we are? Why this one contain only one? Hello. Huh. I'm asking why this support contains only one reaction? Exactly. It's not hinge. It's roller. This one is roller support, and roller support only contains one reaction, which that is perpendicular to the roller side. Okay. Right now the roller is applying horizontally, and this reaction is applying vertically. Okay. This, 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 this. Okay. And right now the whole beam is in equilibrium. You know what is the equilibrium? Actually, the equilibrium is nothing but at a condition where all the net effect of all the forces or moment will become zero. Net effect. This means exactly what the forces are applying on it in different direction, but the net effect on that particular body is neglect, is just zero. Means whatever you are applying on vertically downward, the same is applying towards upward. The final result is zero. The body is not moving in any direction. Okay, this is equilibrium. So the conditions are summation Fv equal to 0, vertical forces, summation of vertical forces 0, summation of horizontal forces 0, and summation of moment at a particular point equal to 0. Clear? The three conditions are of equilibriums are summation of summation of vertical forces 0, summation of horizontal forces 0, and summation of moment equal to 0. Okay. And right now in about this question, in this question there is no any horizontal force in this. Okay, this one is applying on upward, this one is downward, this one is downward, this one is upward. There is no any horizontal force. There is no any horizontal force. Okay. So right now we can apply summation F equal to 0. Summation F equal to 0. Right now we are taking sign convention is this, plus plus plus, as I told you in the previous class. Okay. Sign convention is this. Okay. Right now summation Fp0 means what? Ra in positive direction minus 20 minus 30 plus Rb equal to 0. Clear? Ra plus minus 20 minus 30 plus Rb. So overall the equation is Ra plus Rb equal to 50. Equation number 1. Clear? Hello. Clear? RA plus RB equal to 50. Okay. Right now, just see. Can you see this? RA in positive direction, RB in positive direction, 20, 30 in negative direction, in downward direction. So that's why RA plus RB equal to 50. Okay. And right now we are taking moment. Summation m equal to 0. Okay. And right now we are taking moment. We can take moment at any point. Maybe take at here, or here, or here. Okay. But we are taking the moment at the starting initial point, that is A point. Okay. We are taking moment at A. Okay. Okay. And right now, what I have told you in last class, that the moment is equal to force into perpendicular distance. Okay. Remember? So right now RA is applying on this point. RA is applying at this point. So this does not contain any perpendicular distance. Okay. So this force is this moment of this force is equal to 0. RA into 0. Okay. 20 into 1. 20 into 1. 20 into 1 in this direction. 20 into 1 in clockwise direction. That is plus. 30 into 3 in plus. 30 into 3. Okay. In again clockwise direction. Okay. RB minus 4 RB. Okay. RB into this. Anti-clockwise. Anti-clockwise. The distance is 4 meters. Okay. Sorry, your voice is not clear. RA is applying on this point. That's why it's 0. RA into 0. 20 into 1. 30 into 3. RB into 4. Okay. So right now the equation is 4 RB just 4 RB equal to 20 plus 90, that is 110. 20 plus 90, that is 110. Okay. So RB equal to 100 upon 10, 110 upon 4, whatever the value is. Okay. Clear? Okay. Right now RA equal to 50 minus whatever the value is. Clear? Any doubt? Okay. What was you asking? What was you asking? Inclined plane. Okay. If suppose this one is plane and the force is inclined like this. Okay. And right now it will matter on at where the forces are resolving. Suppose the force is resolving like this. Okay, and the point is at here. Point is at here. This force contains this perpendicular distance. Okay, and this force contains this perpendicular distance. Clear? Is it visible to you? Okay. Right now, just take some another examples. This example is clear to you, or there is any doubt? Okay. Okay. Yeah. You saying anything? Okay. Right now, just take some another example. This one contains two roller supports. This one is UDL. This one is UDL. This is 30 kilonewton per meter applying on the 4 meter. This one is 3 meter. This one is 1 meter. And the magnitude of this is 40 kilonewton per meter. Question is clear to you? This beam contains two UDL of 40 kilonewton per meter and 30 kilonewton per meter, and on the 3 meter length and 4 meter length respectively. Okay, and in the both the distance between both the UDL is 1 meter. Okay, and right now we have to solve this question. First of all, the concept of we have to solve the reactions. This one is roller. This one is roller. Hello. So we will apply the simple vertical force RA RB. This point is A, this point is B, C, D. Okay, clear? Okay, right now the magnitude of this UDL will be, the weight of this force will be 40 into 3. Clear? 40 into 3, that is 120. And where it is applying? It will apply on mid of the length. 120 at 1.5. This thing is clear? What is 120? 120 is small w into length. 40 into 3. 40 into 3, that is 120. And where it is applying 120, it is applying on at the mid of the beam, mid of the UDL. Okay, that is 120 applying at here. And this point is E. Okay, again 1.5. ये 1, and after that this UDL is 13 to 4, 120. 120 applying at 2 meter. Yeah, is this clear to you? No. At the at, at the center of the UDL, the UDL is applying on 4 meter. Okay, na? So yeah, so the load will apply at the half of this. Okay. Suppose if the UDL is applying on the whole length, on the entire length, then it will apply on this. Clear to you? And right now the UDL is applying on at the this length, so this one is the force is applying on half of this, and this load is applying on half of this 1.5, and this one 2. Clear? And right now again we will have to solve summation FP equal to 0. Again at here there is no any horizontal force, yeah. So in summation FV0 it is RA plus RB equal to 240. Clear? Okay. Again, we will take moment like the previous one. Ma equal to 0, Ra into 0, Ra into 0, 120 into 1.5, 120 into 1.5. Clear? Plus in 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 clockwise direction, 120 into 3, 4 to 6. Clear? Okay. And minus 8 Rb. Clear? Is there any doubt? Sorry, your voice is not audible. Hmm. We are taking moment at the A point. Okay. 120 into, okay, okay, okay. Just right now, is it okay? Can you see this right now? 120 into 1.5, 120, 120 into 6, and Rb into 8. Rb into 8 equal to 0. Okay. Right now, we have to solve this. 8 Rb equal to 120 into 6, that is 720 plus 240. I think this one will be 960. Yeah. 8 Rb equal to 960, Rb equal to 120. Rb equal to 120, then Ra equal to or Ra also will be 120. Clear? The question is clear to you and the solution is clear to you? Okay. Right now, we will take a third example. It is of bearing load. Okay. Bearing load. Roller support again. Roller support again. This one is 200 kilonewton per meter. Okay. And the 3 meter and 6 meter. Okay. Question is clear to you? 200 kilonewton per meter. Bearing load is 200 kilonewton per meter. Bearing load is applying at this point, which is 6 meter from A side and 3 meter from B side. And this one, okay. Right now, we have reduced the concept of BLS from 0 to max. Okay. So we have to classify this load into two parts. We have to partition this. The first one is 0 to 200 and the next one is 200 to 0. This thing is clear to you, what I am saying to you? This is RT, this is R. Okay. This is RA, this is RB. Okay. And this VL is 0 to 200. Okay. But I have told you that the loading, the capital W will be half into 200 into 6. Okay, that means 600. That means 600. This section is, hello. Can you listen me? Yeah. What I'm saying is this will further divided in two parts. This one is AC and further is CB. Okay, and this one is half 200 into 6. Half 200 into 6. That is what exactly? 600 kilonewton. Okay, and this one will be applying on two-thirds from this side. That means 4 meter. Clear? Huh? Huh. Huh. Half into 200 into 6. Huh. No, no. The center of this VL will apply on one two-third from the lower end or one-third from the higher end. Just recall the two page before what I've told you about the bearing load. It is applying at two-thirds from the lower end and the one-third from the higher end. One-third from higher and two-third from lower. Lower means from zero. Okay, it should be from zero. Okay, the concept of varying is from zero to maximum. Okay, suppose this one is 0 to 200, so it should be from 0, not from 50, not from 100. Not, you can't take it from here. Okay, you have to take it from this side, from the 0. Okay, is it clear to you what I'm saying to you? Okay, right now this is half 200 into 6, that is 600 kilonewton. That is applying on 4 meter from this end. Okay, after that 2 meter. Okay, and after that this portion, this is half 200 into 3. 3, that means 300. That means 300 is applying at here from 1 meter from this end at here, and this one is applying at here. This is 1 meter and this is 2 meter. Two-thirds from this end. Huh? Huh. From two-thirds from the 0. And right now at here 0 is here. So this one is one-third, two-third of 3. That is 2 meter. Okay. Now it's RA plus RB equal to 900. Okay. RA plus RB equal to 900. After that, summation moment MA equal to 0. Moment summation M. Okay. Moment at A equal to 0. Okay. RA into 0. 600 into 4. 600 into 4 plus 300 into 7. Clear? Equal to 9 into RB. 9 into RB. 600 into 4. 600 into 4. 300 into 7 equal to 9 RB. Okay. And right now it is equal to 9 RB equal to 2400 plus 2100 means 4500 means RB equal to 500. Clear to you? Clear to you? So RB is 500. That simply means RA equal to 400. Clear? Now tell me, is there any doubt related to today's topic? No. So just practice all the topics. Okay. Okay. Just revise it. If there is any doubt, then you may ask me. Oh, okay. Yeah. Okay. RA plus RB equal to 900. 600 into 4 plus 300 into 7 equal to 9 RB. 9 RB equal to. No, we have to find out RA and RB right now. Huh? Right now it is finished. Right now it is finished. In the chapter of beam, we have to find out SFD and BMD. That is shear force diagram and bending moment diagram. Okay, but right now we are just practicing about the support and loading. Okay, okay. When you are when you will be clear about this support and loading, then we will practice about the supports and then we will practice about the shear force and bending moment. RA plus RB, like this: RA plus RB. RA minus 600 minus 300 plus RB equal to 0. 600 plus 300. RA plus RB. These two are working on upward direction. RA plus RB, and these two are working in downward direction. RA plus RB equal to 900. Okay, and after that we are just half. That is your W. That is this magnitude of the loading. Okay, na? Right now your varying load is 200. Your varying load, that is UVL, is 200. It is applying like this: 0, 50, 150, 200. Okay, your varying load is varying from the regularly at the same interval. Okay, that the overall magnitude is 200, half 200 into 3, half 200 into 3, that is 300 kilonewton. Okay, the question is clear to you, solution is clear to you. Okay, then Yusuf, we will discuss and some another topic in the next class. I think this will be clear to you. Right now we were studying about type of supports, type of loading, and type of beams. Okay, and in this the two crucial things are which type of support is applying on the beam and which type of loading is applying on the beam. Okay, and there are three type of loading. First one is point load, second one is UDL, that is uniformly distributed load, third one is uniformly varying load. Okay, and the supports are of three kinds, that is fixed support, hinge support, and roller support. Okay, and the three loadings have their own characteristics, and the three supports contain their own characteristics. Okay, and we have to just manage all the things and have to solve the question. Okay, okay, that's it for today, Yusuf. Okay, okay, just practice all the questions related to this. Okay, next in the next class we will discuss about the truss. Okay, okay, bye bye, Yusuf. Okay, bye. Okay, okay, welcome. Mention.